Installing three-prong outlets with only two wires in a two-wire system and without grounding them is a code violation according to the National Electrical Code. The National Electrical Code mandates that all outlets in a dwelling unit must be grounded. This is a safety measure designed to protect against electrical shocks and fires. Grounding provides a path for fault current to flow back to the source, tripping a breaker or fuse and cutting off the power in the event of a short circuit or other electrical fault. There are several codes of ethics and standards that electricians should adhere to ensuring safety and compliance. Firstly, the National Electrical Code is a comprehensive set of electrical safety regulations developed by the National Fire Protection Association. It provides the minimum requirements for the safe installation and use of electrical equipment. Secondly, the International Code Council Code of Ethics for Engineers, Architects, and related professions promotes ethical behavior by professionals in the building industry, including electricians. Thirdly, the National Electrical Contractors Association Code of Ethics guides the conduct of electrical contractors and their employees, emphasizing professionalism and integrity. Ungrounded outlets present a significant safety risk. They can increase the likelihood of electrical shocks if a person comes into contact with a live wire or faulty appliance. They can also increase the risk of electrical fires due to arcing or overheating. Although the house is a two-wire system, there are methods to install grounded outlets. One way is to install a grounding conductor from the electrical panel to each outlet. This provides a direct path for fault current to flow back to the panel, ensuring proper grounding. If ungrounded outlets have been installed, the following steps should be taken. 1. Contact the electrician who installed the outlets and request that they correct the issue immediately. 2. Contact the local electrical inspector to report the code violation. 3. Consider hiring a different electrician to ensure that the electrical system is safe and compliant with code. Addressing this issue promptly is crucial for ensuring the safety of the home and its occupants. High voltage systems require clear identification to alert personnel to the potential hazards. Wire colors should conform to industry standards, with specific colors designated for different voltage levels. For example, the NECA typically requires specific color coding for phase conductors, the neutral conductor, and the equipment grounding conductor. In a 480-volt system, specific phase colors are often used to distinguish between the different phases. When these color codes are not followed or when warning labels are absent, workers may inadvertently come into contact with energized parts, resulting in severe electrical shock or electrocution. OSHA's electrical safety standards, specifically in 29 Code of Federal Regulations, or CFR 1910.301 through 1910.399, outline the requirements for safe electrical work practices. These standards mandate that employers provide a safe working environment and protect employees from electrical hazards. Key provisions include requirements for lockout/tagout procedures, personal protective equipment, and the proper use of electrical equipment. Employers must also ensure that employees are trained to recognize and avoid electrical hazards. Non-compliance with OSHA's electrical safety standards can result in significant fines and penalties, as well as potential legal liabilities in the event of an accident. It is crucial to document all instances of non-compliance and safety violations. This documentation can include photographs, written descriptions, and records of conversations with supervisors or management. Maintaining a detailed log of safety concerns and the responses received can provide valuable evidence if further action is required, such as filing a complaint with OSHA. When discussing safety concerns with an employer, it is important to present the information clearly and professionally. Put concerns in writing outlining the specific violations of the NECA and OSHA standards as well as the potential hazards they pose. It is also helpful to provide specific recommendations for corrective actions, such as installing equipment grounding conductors, correcting improper wiring practices, and providing appropriate warning labels. If the employer is unresponsive to initial attempts to address the safety concerns, a formal complaint should be filed with OSHA. OSHA provides a confidential process for employees to report workplace safety violations. When filing a complaint, provide as much detail as possible, including specific dates, times, and locations of the violations, as well as any supporting documentation. OSHA will investigate the complaint and may conduct an on-site inspection of the workplace. If violations are found, OSHA can issue citations and require the employer to implement corrective actions. It is important to understand the relevant sections of the NEC and OSHA standards that apply to electrical installations. For example, NEC Article 250 covers grounding and bonding requirements, while OSHA's Electrical Safety Standards in 29 Code of Federal Regulations, or CFR, 1910.301 through 1910.399 provide comprehensive guidelines for safe electrical work practices. By familiarizing oneself with these standards, one can better identify and address potential safety hazards. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to return to the source, while bonding ensures that all metal parts are at the same electrical potential. Proper grounding and bonding minimize the risk of electric shock and equipment damage. In electrical systems, several types of grounding are employed. These include system grounding, which grounds the neutral point of a power supply, and equipment grounding, which grounds non-current carrying metal parts. Each type serves a specific purpose in enhancing safety. Bonding involves connecting all metal parts of an electrical system to create an electrically conductive path. This path ensures that if a fault occurs, the fault current will safely return to the source, tripping the overcurrent protection. Bonding can be achieved through various methods, including the use of bonding jumpers, bonding bushings, and grounding electrodes. Grounding electrodes are used to connect the grounding system to the earth. Common types of grounding electrodes include ground rods, ground plates, and underground metal water pipes. The selection of the appropriate grounding electrode depends on site-specific conditions and local regulations. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits from overloads and short circuits. These devices are designed to interrupt the flow of current when it exceeds a predetermined level, preventing damaged equipment and reducing the risk of fire. Electrical equipment should be installed according to manufacturer's instructions and relevant electrical codes. Regular maintenance, such as tightening connections and replacing worn components, can help prevent electrical hazards. In hazardous locations, such as areas where flammable gases or vapors are present, special electrical equipment is required to prevent explosions. This equipment is designed to contain any sparks or arcs that may occur within the enclosure, preventing them from igniting the surrounding atmosphere. Lockout/tag-up procedures are used to energize electrical equipment before maintenance or repair work is performed. These procedures involve isolating the equipment from its power source and applying locks and tags to prevent accidental re-energization. Personal protective equipment, or PPE, such as rubber gloves, insulated tools, and safety glasses, is essential for protecting electrical workers from hazards. The type of PPE required depends on the specific task and the potential risks involved. Electrical safety training is essential for all personnel who work with or around electrical equipment. Training should cover topics such as electrical hazards, safe work practices, and the proper use of PPE. Regular refresher training should also be provided to ensure that employees remain up to date on the latest safety procedures. Electrical accidents can have severe consequences, including electric shock, burns, and electrocution. Understanding the causes of electrical accidents and implementing preventive measures can help reduce the risk of these incidents. First aid procedures for electrical shock victims include immediately disconnecting the victim from the power source and calling for medical assistance. CPR may be necessary if the victim is not breathing. Regular safety meetings can be used to discuss electrical safety topics and reinforce safe work practices. These meetings provide an opportunity for employees to share their experiences and learn from each other. Electrical safety audits can be used to identify potential hazards and ensure that safety procedures are being followed. Audits should be conducted by qualified personnel and should include a review of electrical installations, work practices, and training programs. In summary, Addressing electrical safety concerns requires a comprehensive approach that includes compliance with electrical codes and standards, proper training, and the implementation of safe work practices. By taking these steps, employers can create a safe working environment and protect employees from electrical hazards. The goal should be to prioritize safety by implementing comprehensive measures that address potential hazards and ensure compliance with relevant regulations. This includes not only the proper installation and maintenance of electrical equipment, but also the continuous training and education of personnel. By fostering a culture of safety and accountability, organizations can significantly reduce the risk of electrical accidents and protect the well-being of their employees. Ensuring that all electrical work is performed by qualified and licensed electricians is a fundamental aspect of maintaining safety. Licensed electricians have the necessary training and experience to install and maintain electrical systems in accordance with established codes and standards. This helps to minimize the risk of errors or omissions that could lead to hazardous conditions. Conducting regular inspections of electrical installations is essential for identifying potential problems before they escalate into safety hazards. These inspections should be performed by qualified personnel who are familiar with electrical codes and standards. Inspections should include a thorough examination of wiring, connections, and equipment to ensure that they are in good working order. Implementing a robust lockup/tagout program is critical for preventing accidental energization of electrical equipment during maintenance or repair work. This program should include clear procedures for isolating equipment from its power source and applying locks and tags to prevent unauthorized access. Providing employees with the appropriate personal protective equipment, or PPE, is essential for protecting them from electrical hazards. This may include items such as rubber gloves, insulated tools, and safety glasses. Employees should be trained on how to properly use and maintain their PPE. Establishing clear communication channels is crucial for ensuring that safety concerns are promptly addressed. Employees should be encouraged to report any potential hazards or safety violations to their supervisors or safety managers. Management should be responsive to these concerns and take appropriate action to resolve them. Continuously monitoring and evaluating the effectiveness of safety measures is essential for identifying areas for improvement. This may involve tracking incident rates, conducting safety audits, and soliciting feedback from employees. By using the grounded conductor, as both the grounding and grounded conductor creates an unsafe condition, it is essential to separate the functions of the grounded neutral conductor and the equipment grounding conductor to minimize the risk of electrical shock and equipment damage. The equipment grounding conductor is dedicated to providing a low impedance path for fault current, while the grounded neutral conductor carries the normal return current from the electrical load. When these two conductors are combined, fault current can flow through the grounded neutral conductor, potentially energizing any metal parts connected to it. This can create a shock hazard for anyone who comes into contact with these metal parts. In addition, the flow of fault current through the grounded neutral conductor can interfere with the operation of sensitive electronic equipment and increase the risk of fire. Using the wrong wire collars is another serious safety hazard. Wire collars are used to identify the different conductors in an electrical system, such as the phase conductors, the neutral conductor, and the equipment grounding conductor. Using the wrong wire collars can create confusion and increase the risk of electrical shock or electrocution. For example, if a worker mistakenly identifies a phase conductor as the neutral conductor, they may come into contact with an energized part, resulting in severe injury or death. It is essential to use the correct wire collars and to clearly label all conductors to avoid confusion and prevent accidents. The lack of training for non-licensed and inexperienced workers is a major concern. Electrical work can be dangerous, and it is essential that all workers have the necessary training and experience to perform their jobs safely. Non-licensed and inexperienced workers may not be aware of the potential hazards associated with electrical work, and they may not know how to properly use tools and equipment. This can increase the risk of accidents and injuries. Employers should provide adequate training for all workers, regardless of their licensing status or experience level. The training should cover topics such as electrical hazards, safe work practices, and the proper use of personal protective equipment. Also, the specific requirements for highway lighting and traffic control systems, which often involve unique challenges and considerations, should be addressed. The fact that the state exempts itself from the NECA does not mean that it is exempt from all safety regulations. OSHA has the authority to regulate workplace safety in all states, including those that have exempted themselves from the NECA. OSHA requires employers to provide a safe workplace and to protect employees from electrical hazards. If an employer is not complying with OSHA regulations, employees have the right to file a complaint with OSHA. OSHA will investigate the complaint and may conduct an on-site inspection of the workplace. If violations are found, OSHA can issue citations and require the employer to implement corrective actions. It is important to remember that safety is always the top priority. If something does not seem safe, do not do it. Always follow safe work practices and use the proper personal protective equipment. If there are any questions or concerns, consult with a qualified electrician or safety professional. In addition to OSHA, there may be other state or local agencies that have jurisdiction over electrical safety. It is important to be familiar with the regulations of all applicable agencies.